Welcome back. It's time for number 6 on our first side of this handout. It's actually problems 31 and 36 at the end of section 33. And the question is, find the least possible degree of the polynomial functions shown. And one thing that we can notice is that this first one is 31, is that we have x-intercepts at negative 4, negative 1, and 4. So that means that f of x must have factors x plus 4, that's for that x-intercept, and x plus 1, that's for this intercept, and an x minus 4. And there may be some other factors, and there might not be. But there's at least 3 factors, so that says that the degree is at least 3. But one other thing, 3 roots, those numbers are called roots or zeros or x-intercepts. That means that the degree of f is at least 3. But there's also one other thing to notice, is that we have turning points. Over here and over here, these are called turning points. And a turning point, it's an easy idea. The function is going up, and then it turns around and goes down, and then it goes back up again. So the behavior changes. It's increasing and then it's decreasing, or it's decreasing then increasing, and that's called a turning point. If we count the number of turning points, 2 turning points, what that means is that the degree of the function must be at least 1 more than the number of turning points. So 3, it agrees, the degree of this function must be at least 3, and seeing those factors, that's actually a potential for the function. We may have to scale it with a coefficient, but the degree is at least 3. Let's move over to number 36 and count the number of roots and also the number of turning points. Okay, for roots, well, we're looking for x-intercepts. I see 2 roots, and this implies that the degree of this function must be at least 2. It's just the number of zeros or roots. The degree is at least as big. But if we count the number of turning points, there's 1, 2, 3. There's 3 turning points, and that implies that the degree of the function must be at least 3 plus 1 more, or 4. So one is telling us that the degree is at least 2, the other is telling us the degree is at least 4, and altogether we can conclude that the degree of this function, is at least the bigger of the 2, which is 4. So the one on the left, at least 3, the one on the right, at least 4, based on the number of turning points and the number of zeros. So let's pause here, and we'll move on to number 7 in the next.